Broadcast. Hey, welcome everybody to Astronomy Daily Live. Hope everybody's doing well out there in the universe and the world. Everything's good here. It's cold. It's cold. We actually got about that much snow is on the ground right now. It snowed a lot of the day. And about 15 minutes before sunset, the sun came out, and so everything started to melt. And the sun went down, and now it's well below 0 Celsius. So yeah, it's going to be a cold night. But it's winter time. It's winter time. So I mean, come on, what do you expect? However, the interesting thing, one of the things that a lot of people don't quite comprehend because it goes against common sense, right? I understand this. Don't rely on common sense, right? Because that can steer you wrong, right? It is wintertime. In the northern part of the planet, right? However, in about 3.5 hours, and we'll actually look this up soon here to get the exact time. But in I think in just a few hours or so is perihelion, which is Earth's closest approach to the sun. So we're actually as close to the sun that we're going to get, this time around. So common sense would say, okay, it's cold outside. It's cold outside, so we must be furthest from the sun. But no, it's exactly the opposite. January 1st, 2nd, 3rd is actually closest to the sun, and sometime in June 3rd or 4th or 5th or 6th or something like that, we're actually furthest from the sun. So actually, those folks in the south of our planet actually get a little bit more intense summer. Than us here, just because we're a couple of million miles closer to the sun, and so the intensity is slightly more. So yeah. So happy perihelion to everyone too. We're going to look up the numbers here in a little bit. So very cool. It's always nice. Once again, this is one of those shared experiences that everybody and everything go through, whether you know it or not. So yeah, perihelion, once again, it's totally amazing. All right, well, once again on the panel is Bobby. Hey, Bobby, with the headphones.
Hey, what's up? Kind of made crazy yesterday on the pre-show. You was like, what? And I was like, dude, I got headphones.
And they glow too. They got little lights in them and everything. Wow. Yeah, gee whiz. Very cool. And yeah, you can hear better. We can hear better. So, win-win all the way around.
Winner chicken dinner.
Yeah, that's exactly how it goes. Now, for us vegans, vegetarians, I don't know, we're going to have to come up, with something else there, but that works really well. So very cool. And also there is Tom. Hey there, Tom.
Hey, hope everybody's doing well tonight. I have headphones too, but mine don't have any glowy lights on them or anything like that. They're just stupid, I guess.
I don't either. These are just the boring old things, no lights, no flashing lights, no microphone thing, no nothing at all. I'm using the mic and the camera there. Yeah, no fuss, no muss. My thing, is keep it simple, right? Just not necessarily, junk stuff, right? But keep it simple. We like to put lights on everything now. So that is very, very cool. Very cool. Yeah. So hope everybody's doing well out there. The New Horizons team just posted their first pictures of Ultima Thule over on their raw image site. These raw images, though, are JPEGs. So I'm sort of like, all right, well, okay.
What is normal for a raw image?
Well, most likely what happens, and this is simplified because I don't know, but I think what normally happens, right, is that they get the signal down from the spacecraft, right, and it goes through the deep space network, and that data is packaged up in some kind of way, right? And then that data is sent to the New Horizons team, right?
Now,
and
can we look at that picture right now, or we gotta wait a while?
What, you mean the picture I was just referring to?
Yeah.
We can take a look at it. Sure, absolutely. Yeah.
Yeah.
Yeah. Well, let's do that in a couple minutes. So the New Horizons team gets this stream of bits, right? And they run that through some kind of a process, right? I have absolutely no idea, right? But it's some kind of process, to turn them into pictures, maybe do calibrations. I have no idea, right? But some kind of process, to turn them into a picture. Usually at that point, it's put into some kind of a format, right? Like FITS, or some kind of a format where you have like a header that has all kinds of metadata, right? The size of the image, the time it was taken, various pieces of telemetry, gain, exposure time, all kinds of information, right?
So let's just say you're more of a FITS person, right?
I love having FITS. I like to have FITS all day long, just FITS and FITS and FITS and FITS and FITS. Yeah. but and most of the scientific data is sort of delivered that way, either FITS or some kind of similar thing, right? Where there's some kind of header and then all the data. And that's how you'll find it over on the planetary data system. You go over there, look at their data releases, and it's usually, might be a text file, with a bunch of columns, right? That shows telemetry, temperatures, and pointing directions, and all kinds of things, right? So, sometime.
And Earth Radio wants to ask a off-topic question, if that's okay.
Oh, sure. In fact, I should have been looking in the chat already, and I wasn't. So I want to say hi to Ron and Andy, both the guys in here. Who else we got? 9 Inch Colas. Hey. Yeah, what is your off-topic question, ERRT Radio? We can, we can definitely deal with that. How long does it take something to be petrified? Ooh. I'm not exactly sure. I think it sort of depends on the conditions that it sort of finds itself in. Now, of course, if you're referring to, how long does it take, to petrify someone in sort of the scared sense? Well, that can be really quick. I don't think that's what you mean, though. It depends on the process and the material that is being petrified, and also what it's in, right? Because like electricity can petrify things, turn things into stone really fast. But also, long periods of time. I'm not exactly sure.
I remember being electrocuted at the age of 5.
Ooh, how did that feel?
Oh my gosh! It's like, get me off, please. Because my head was burning, everything was burning.
Oh no, yeah. See, if there was a safe way to be able to, feel and experience, that kind of current, I would love to do that. I would love, because
it wasn't being electrocuted. I was actually getting arced.
Yeah. Oh, yeah. And that's probably even worse, right? But yeah, that is a very, very interesting and weird sensation. I've, being in electronics, I've gotten zapped, many times. Not with anything too much. I don't think anything more, the 120 volts. But coming out of the wall. So that can be.
How about like touching the heat, the heating tip of the soldering iron? You'll be like, oh my gosh, it burns.
Oh, I've done that so many times I can't even count.
Yeah, I think.
Yeah, that just goes with the job. So.
Okay. So check the chat.
Yeah, I'm looking at it. Crooked Ninja 5. Yeah. Like I said, I'd like to be able to experience that for a longer period of time, but it's very unhealthy. It's extremely unhealthy. So, yeah,
don't do it.
Don't do it.
Otherwise, you'll definitely be shaking hands with danger.
Yeah, Nikola Tesla did a lot of those kinds of experiments, but he knew what he was doing, right? So he would do these like huge voltage things. And
like almost touching the coils and stuff, right?
Yeah, but I think extremely low current, or he made sure that it didn't go through him, or I'm not exactly sure how he did it. He was a genius. So I have no idea.
I think Tesla did some things a couple times where he hurt himself and just didn't let on because he was being a showman. But
I see.
I don't think always did it safely.
Yeah. Well, You know, you got to, well, obviously, got to be careful with those kinds of things. You got to know what you're doing, and when things are turned on, you've got to know, what to touch and what not to touch, and what the paths are. Low current, low voltage kinds of things, though, are actually very, very healing. Right? I've got a friend who he's got this. It's some kind of a. It's not exactly like a bath thing, but it's some kind of a thing, like a vessel of water that he puts on the floor, fills it with water. I'm not exactly sure what kind of water it is. It's water, with something else in it, and it has some kind of an electrode there, that your feet touch, and then some kind of a hand thing that actually, completes the circuit. He plugs it in, completes the circuit, and it's something like, I want to say like 9 volts or 12 volts, really, really, really low current. And, he swears by it. He thinks it's really, really great. He's gotten snake bites and stuff, that he'll actually take like a cattle prod and, zap himself, and he's fine. Snake bite goes away. So, these kinds of electrical things, I think, work. You just have to be.
Have you ever had to be involved in an electrical cautionary?
I don't know what that is.
Oh, it's I had to do one of those from a big skin tag I had right here underneath my arm. So, like, what the doctor did is he numbed it, and then he uses that electrical cautionary probe to take the tag out.
Interesting.
And it was a big tag too.
Interesting. Very cool. Very, very cool. Yeah, so ERT thinks that he's found a petrified bone, a human bone. Yeah, I don't know. Yeah, you'd have to show it, to somebody, who knows those kinds of things. So petrified, though, is a very, very specific definition, though. So you sort of have to be careful with that term. Because bones can lay outside and dry out and seem to be petrified, right? But I think that has sort of a very, very specific definition. Tom, you might know, is there anybody on Twitch, like a geologist or somebody who might be able to answer that kind of question about petrification?
Sure. There's a woman who goes by the name of Rocket Sage. She's a geologist. She's teaches at a university in West Virginia, I think. She does a stream 3 or 4 times a week, and would probably know a lot about that subject. Yeah. I can put her link in the Discord or in the chat or something.
Do it. Do it. Yeah. I don't know if that's a geology question or a biology question. I don't know.
I think it's geology, because it's kind of a sedimentary process, where you sit in water and each of the molecules of the wood or whatever gets replaced with silica or some other kind of element. But
Tom will post a link to Rocket Sage. Like he said, she's over on twitch.tv, and she does a live stream a couple times a week, you said. That would definitely, or probably at least, be a question for her. She might, be able to direct you in a better way, at least.
Absolutely, yeah. If she couldn't answer it herself, I'm sure she knows someone who could.
Mm-hmm. Very, very cool. Yeah, where I am, there actually are a lot of petrified trees and those kinds of things around me. So yeah, familiar with that kind of stuff. But what exactly, the definition of that is, and what to look for, and all that, I don't have a clue. I just do astronomy. I can't do any of that hard stuff. What's that, Bobby?
Bob, I had a shock therapy to stimulate his muscles back when he blew his ACL. That was some good stuff. And Ron, he had it for a while, either in Ohio or Wisconsin. It's not Skype. It's called Google Hangouts, and you just email him and say, "Hey, I want to be on a panel," and he'll put you on the spot.
Yeah, just ask, and I will send you the link. That's sort of the easiest way of doing that. So yeah, well, cool. Let's what I like to do at the beginning of each month, and I should have done it yesterday, but I wasn't paying attention to what day it was. I like to go over to Cloudy Nights at the beginning of each month. There, they post sort of events for the coming month. Things are going to be happening in the sky. Planets and.
And what about that Ultima Thule picture? Are you still going to show that?
Yeah, we can take a look at that first.
Okay.
Anyway, yeah, just to finish out that, what they posted are JPEGs, right? So this data has obviously gone through some kind of process, to come out, at least one of these ends with JPEG images, which are pretty useless in terms of doing science, right? Because they are compressed. You really don't know what the numbers are, but just to look at them, yeah, it's nice. It's nice. So you've got a clear sky tonight there, huh? Yeah, I actually have a clear sky too, but the humidity is 100%, which is extremely rare, for being here. And it's in terms of Fahrenheit, I think it's supposed to get into the single digits here, which is also pretty rare. That happens a couple times a year. And this is going to be one of those cold nights. So this is about as cold as it gets. And like I said, we've got about that much snow on the ground too. So I don't like it at all. Don't like any of it. But it does make things look really, really nice, really, really cool. So, all right, cool. So let's go over and look at Ultima Thule. And probably what I should, I did post, I think I posted a link to today's press conference. So I think I put it over on the Discord server. So check that out, because, of course, those folks are going to explain things much better, than I'm going to. And pretty exciting stuff. Looks like, they've got a lot of work going, and I don't know if they. I don't think that even they have seen sort of the highest resolution pictures yet. Oh, phone ringing. You know, they're pretty excited about things. So, all right, well, very, very cool. Let's go over and take a look at the Ultima Thule pictures. Let me get that set up here. Ah, it's already here. So let me share my screen like that. Go to infinity. Boom. I wonder what's back there. How far does that go? I don't know, man. That seems to go really far. I don't know. I'd sure like to go. All right. So these are the two that I was referring to. Let me zoom in a little bit here. Let's see if I can. It looks like the pictures are staying the same and the text is getting smaller. So yeah, it's kind of hard to see, but these dates are from December 31st, but these ones are from January 1st. This one was taken, it looks like at 4:22 UTC, which is what, about like an hour before closest approach. And same with this one, about 1 hour before closest approach. So yeah, you know, they don't even have, you know, the closest approach shots yet. I'm at least not here. So yeah, let's take a look at these. They seem to have come in sets of 3, which again, I'm not exactly sure why they came in sets of 3, but they did. So let's see if we can zoom in a little bit here. Take a look at this. Oh, am I gonna mess all that up? Oh, I am. Uh-oh. There we go. Let me see if I can. There we go. There we go. So there's at least one of the shots. You can definitely tell, you know, that it's double lobed, connected in the middle. But, you know, the sun is shining right down on this, right? So we're not really seeing, you know, shadows or anything like that. You know, it's hard to see. It looks like there are some background stars here. Maybe cosmic rays. You know, it's hard to tell. We'd have to, you know, play with the image. And like I said, you know, this is a JPEG image, so it's not going to look pretty. You know, this is probably about as good as it gets. But there's actually 3 of these. Maybe 3 different colors. I'm not exactly sure. Not exactly sure why there's 3 of them. Haven't really looked all that hard because during the press conference, you know, they actually showed these and showed colors and everything else. So I wasn't too motivated, you know, to do that myself. But looks pretty nice. You know, they describe the darkness of this thing as being like as dark as potting soil. Right, you know, so pretty dark. They actually say what the exposure time is here. Well, let me zoom back out. So point.
Zoom back out some more. Oh, there you go.
Yeah. So the exposure time here was 0.15 seconds, right, at a range of 148,795 probably kilometers. So that's pretty cool. We can look at the next one too. This one looks a little bit brighter. I'm not exactly sure why, because the exposure time was exactly the same, and it was actually taken from a little bit further away. So they probably played with the contrast and the brightness a little bit. They goosed it up a little bit, and got that. So that's pretty nice, pretty cool. And again, it's hard. Kind of hard, to tell if these are background stars. Here, let me zoom in again. If these are background stars, or if we're looking at, like cosmic rays, or if we're looking at noise. But they're a little bit fuzzy. So my guess is that, some of these are stars. Maybe these are, little like little moons, right, or something. Who really don't know yet. There is definitely what looks like a dimple here of some sort. The where these two things touch seem to be a lot brighter, than most of the rest of it. But there are some dark patches. I can zoom in a little bit more, I think. Not zoom in a little, or dark patches, light patches. So yeah, we'll see. So yeah, pretty exciting. It's rocks and dirt, so very, very cool. We like rocks and dirt, especially that far away. All right, we're talking. This thing is 6 billion kilometers from the sun, so it's way out there. We have never been this close to anything that far out. Now the Voyager spacecraft are much further out. They're about.
Look at Ninja just posted the link in the chat and stuff. Nightbot didn't like it.
Nightbot is just gonna nail Crooked Ninja to the wall. That's it. That's it. Zoom in. Looks like a peanut.
Is there any way that we can add an exception for people that can be allowed to post links?
I'm not sure. I think I think I might be able to. No.
Without adding moderator status or anything.
Yeah, I don't think I can. I'll look into that a little bit. Let me see if I can. Oh, I didn't mean to do that. I meant to do. Yeah,
copy.
Yeah. Let me see if I can copy link address and post it here. There we go. So that'll do some kind of redirect, it looks like, but maybe that will get us to where we want to go. So yeah, I sort of have a little bit of gripe. One of the first things that we humans do is we try to think about what this thing looks like. What does it look like? And my response is it doesn't look like anything, right? It looks like exactly what it looks like. That's it, right? I mean, why does it have to look like anything? I don't get that. I think it's awesome, just the way it is. So, that's just a little, pet peeve on my part, I guess. But I think it's absolutely fantastic. Now, these images were taken when New Horizons, was still like 150,000 kilometers away. Now it got to within about 3,500 kilometers. So we ain't seen nothing yet, nothing at all. Tomorrow's briefing at 2 p.m. Eastern time. I think they're going to show more images closer up. I think they may also have some spectra. Stay tuned. And as far as I know, they're going to be posting at least the pictures on this site, which I will. Let's see. Is this? I guess this is the one. Yeah. Let's. Here. Let me see if this goes. Does this go to? It does that. Okay, good. So yeah, let me. I will post this in the
if
chat
they were
too.
now looking at the site and stuff, it says it's in raw format. But why they But you said they're in JPEG. So what makes you think that JPEG is not like raw?
JPEG is definitely not raw. Yeah, I mean the cameras that are used to capture these pictures are CCD cameras, 1024 by 1024, 12 bits. So these are coming down in streams of bits, right, ones and zeros, and constructed. So yeah, like I was saying, those bits are going through some kind of a processing pipeline to come up with these JPEGs. I mean, now I could be totally wrong about this, but I don't think I am. JPEGs are just sort of convenient, because computers, people's computers, can deal with those, right? Most people's computers can't deal with FITS images or any of these other formats. So they put put these pictures into formats that most people can deal with. So
like PNG, JPEG, and GIF, right?
Yeah, exactly. Yeah.
So there is a legitimate reason, and then there's the no reason.
Well, yeah, I wouldn't use a JPEG image, to do any kind of scientific analysis, right? Beyond, just what we did, right? Looking at it and saying, oh, okay, here's the shape. There's some, dark parts, there's some light parts, there, some background stars. That's about it. But actually making measurements, you can't really use a JPEG image, because there aren't any data values associated with them, right? There's red, green, blue values, and that's it. So, yeah. All right. Well, cool. Enough about that.
Do they stack the images?
My guess is that these are single images. Like I said, I'm not quite sure why there are 3 of them per set. Maybe that's some kind of red, green, blue thing. I'm not exactly sure. Yeah, don't know. All right, well let's move over to cloudy nights here and at least start, because I'm looking at the time here and it's already 2:39. Let's at least start looking at the celestial events for January. And actually, one of the first things that I wanted to do was actually jump off of this right away because Saturn actually was in conjunction with the Sun yesterday, almost 24 hours ago. And when it's in conjunction with the Sun, oftentimes we can go over to the SOHO spacecraft site, which is looking at the sun, and we can actually see Saturn and actually many of the planets close to the sun. And I like to do that. So let's go over there just really quick and take a look. Soho has these two really cool views. One is called LASCO C2, the other is called the C3. C3 is kind of a wide field of view, and C2 is a narrower field of view. Both looking at the sun, but what they've done is they've sort of stuck this thing right into the field of view and blocked the really bright light from the sun to reveal some of the structure of the corona and also the background sky. See all these things? These are all stars, right? These are all stars here. Now, I guess not all of them are. Some of them are probably cosmic rays. Some of them are noise. So yeah, this is extremely cool. But what we can do, and as you can see, this is sort of the latest one that was taken on January 2nd at 20:06. So that was about what, 6 hours ago, 6.5 hours ago. Now they don't always do a good job keeping these right up to date, but I'm absolutely thrilled to have any kind of view of the sun like this. Be able to see structures like this and have a background sky, that I think is extremely cool. They also have these movies, and you see this guy right there, that is Saturn. You can see the date, right? So this was a few days ago, and as you can see, it's slowly moving along with all the other stars. Once this loads, it'll go into a loop and it'll be a little bit faster. But you can see that all the stars are slowly moving to the west, and Saturn is too. Now Saturn is on completely the other side of the sun right now, right? So we're on this side of the sun, and then there's the sun, and then there's Saturn actually going behind this thing that blocks the sun out. So you can see, all kinds of other things, cosmic rays, actual particles from the sun that are hitting the CCD camera, and getting those electrons all excited and showing a detection. And yeah, so there's a variety of those. There's a science in those, just just in all those streaks, right? You could spend a lifetime, just studying that. But I'm trying to see if we can pick out any constellations here. Sometimes you can, and sometimes you can't. So now it's sort of going much faster, as you can see. And right at the end here, you'll see it sort of poke out here. Oh, I guess not. But here's the Milky Way over here, just sort of leaving the field of view. But you can see that the corona changes, and you can see little things blowing out here from time to time. And the sun is not very active at the moment, so we really don't have a lot of stuff being blown out. But you can see, these lighter streaks and darker streaks are constantly changing shape and position and everything else. The sun is a very dynamic place. So we've got this other view, which is a narrower um, field of view. Same, they put a device in here to sort of block most of the light of the sun. And then I think with software, they sort of covered up all the ugly stuff. Here's where the sun actually is, right? And you can see that there's just some amazing structures in the corona here. And here comes Saturn, right? There it is. And see, this was a few days ago. According to Cloudy Nights, what did it say? That the conjunction was at 6 hours on the 2nd. So let's see, that's when Saturn would be, right in alignment with the sun. Now, as you can see, it's not going to pass exactly behind the sun. It's going to be a little bit to the north of the sun. But as I say, with software, they sort of blocked out this part because that device that actually blocks the light from the sun makes the image really, really ugly looking, diffraction and all that. But there's Saturn's coming out there. So yeah, I guess that's probably a good estimate. Here comes, okay, there's a star. Here comes, I'm not sure if that's a star or, yeah, that's probably a star. I don't think that we can see any of Saturn's moons, but yeah, pretty close to 6 hours, I would say, is when Saturn was, as close to behind, the sun as it's going to get. So that's always exciting, to see those kinds of things. I actually posted over on the Discord server. Let's see, where did I put that? Did I put it on the science channel? Yeah, this thing, which shows, oh, of course, it's going to be really, really big. So here's the C2 view, which is this red one. And you can see that over the course of the next year, there are going to be a few objects going in that field of view. Venus is going to be going that way. I don't know which one that is. Looks like Mars is going to be going that way. All right. Mercury is going to be going that way. I thought that there was a Mercury transit. Yeah. So Mercury is actually going to be passing in front of the sun. Remember, this circle here is actually the disk of the sun. And as you can see, this path of Mercury is going to be going through inferior conjunction. It's going to be passing between the Earth and the sun, which means it's going to look like it's going to be transiting the sun. So, the second week in November, we're going to have a Mercury transit that looks like, wow, it is pretty much going to go right through the center of that thing. So that's pretty cool. That's pretty cool. There's only, I think I'm right in saying this. I think there's only three. I think there are only 3 objects. Well, 3 easily visible objects that we can see pass in front of the sun, right? And that is Mercury, Venus, and the moon. I think there are probably smaller objects, but those are pretty hard to see, right? And I guess this looks like some kind of comet, right? 322P Soho, is that a comet of some sort that's going to be going around? I had to check that out. I hadn't heard about that one yet. So yeah, very, very cool. Very cool. Anyway, so I'm going to turn this off because, how having that run on this old potato here might bring it to its knees. So anyway, so that happened yesterday, all right, almost 24 hours ago, conjunction with the sun. Let's see. And then, yeah, here is Earth at perihelion. That's happening at 5:20 UTC today. So in 2.5 hours, we are going to be as close to the sun as we're going to get this time around. So very, very cool. Happy perihelion, everybody. Very nice.
And by the welcome Uncle Bill through and in the chat. Just logged in.
Hey there, Uncle Bill. Welcome, welcome. We're just looking to see what's happening over the next month here. I like to do that at the beginning of the month. So, we're sort of at least, set the alerts, set your calendars, if you if you're interested in any of these kinds of things, you can set your calendars, set your clocks to see these things. Let's see. The Quadrantids meteor shower is peaking on the 4th, which is tomorrow at 2:30 UTC. So if you're into meteor showers, and now is a good time, because the moon is pretty much gone.
Hey,
so,
Ron wants to know when is the lunar eclipse. He has conflicting dates.
I think it's this month. We can actually cheat and go forward a little bit and find out that the now here they're actually calling it a partial lunar eclipse. We looked at this before, and eclipse. Let's go over to the lunar eclipse page over at NASA and see what they have to say about this. January 21st. I'm kind of curious to see why they're calling it a partial. Because that to me sort of infers that it's a total. And actually looking at the picture, right, that's a total. But Cloudy Nights is calling it a partial lunar eclipse. I
don't know where he's getting that information from, but if NASA says you get a partial, and he said not partial, a total, and he's saying that we're getting a partial, I'd like to know where he's getting all that information at.
Yeah, not exactly sure. Uh-oh. Got a doggy alarm. Let's see. Also, the times look different too, right? Greatest eclipse they're saying is here's at 5:13, and these guys are saying 5:12. Okay, that is good enough. So yeah, I'm not exactly sure why they're calling this a partial, but looking at this, this is definitely a total, right? That just means that the entire moon is in the umbra of the Earth, the darkest part here. So that is definitely a total for sure. But anyway, ERRT, this eclipse starts.
I think Uncle Bill has a point. Maybe it depends on the observer's location. Some people will not see the total portion.
It's on
the chat.
Yeah, Uncle Bill, I'm not sure about that. I don't know if it necessarily depends on your latitude all that much. Maybe it does, maybe it doesn't. Yeah, I can't be exactly sure about that. Can't be exactly sure. You might be right about that. You might be.
Yeah, I think
Anyway,
he's right about that.
okay.
Space.com says it will be visible. The total lunar eclipse will be visible from North and South America, Europe, and
Yeah.
Africa. So parts
Yeah.
of Asia won't see the whole thing.
Yeah, but that's just because of just the timing of this, right? It has nothing to do necessarily with latitude. That has to do with longitude, right? But
Right.
I think looking at the map, right? I mean, they're going to see a total way down here, and they're going to see a total way up here, right? Aren't they? I don't know. I think so. So, the timing, of course, right? Because, the moon has to be in the sky in order to see it. But I think the totality, I think that's a pretty broad area in terms of latitude. So,
And Uncle Bill Duran said that's the kind of event where UTC really matters. Not like those of my screenshots where I post them in local time.
yeah. Anyway, so yeah, what that's happening on the 21st UT time, right? So 5:12 UT on the 21st. So you have to make sure to correct for your own local time, right? Here, I'm 7 hours behind UTC, so that would put
And I'm behind.
Right. So that would put my time here at 10:12 p.m. on the evening of the 20th. So
maybe you should do an observation on that.
I might. I did. I actually did one. I think it was like last summer or so. I think I did one of those. I forget which one it was. I think it was the one in August. No, the one in July. I think it was the July one. It was either the July one or the January one. I forget which. It's probably the January one. I don't remember exactly. Yeah. Anyway, I did live stream one of those. I think a lot of people are going to be live streaming this again, and yeah, my sense is that we should probably jump onto those instead of trying to do it here. I think that's a lot more fun. Anyway,
the right track is the longitude time zone mostly that affects how much the observer sees, says Uncle Bill.
Yeah. I'm just questioning why Cloudy Nights is calling it a partial when it most definitely is not going to be a partial.
Can you email the poster since I don't think there's no reply option?
I suppose I probably could. I don't know if there's any point to doing that. But yeah, maybe there is an explanation because I don't claim to know anything, so don't know. All right, let's go through a few more of these, and then we'll call it a night here. So let's see. Definitely, if you're into meteor showers, tonight and tomorrow night is definitely your night. In fact, let's do this once again. Let's go over to another site. It's the oh, what's that place that has the meteor count? The International Meteor Organization, is that what it's called? I don't remember. IMO. Oh, wow. How did I remember that? I don't know. Let's go over here and see.
Capture some media scatter stations.
Absolutely, absolutely. You know, you can actually hear meteors on your radio almost all the time. Almost all the time. Let's see. Is it this one? I'm trying to remember now exactly. Visual meteor database, live zenith rate hour. Okay, so we're going to go for the Quadrantids. This one, 2019. Okay. So let's see if they have a graph here yet. I don't.
Probably nothing yet.
Yeah, that's kind of strange. Wasn't it the Quadrantids? Yeah.
Hey, good night, Andy.
Good night, Andy. Thanks for coming in. Let's just do it for 2018 really quick. I'm not quite sure if they. Okay, well, that was definitely last year, right? Because they have data from the 7th of January. So, I guess for some reason they don't have the 2019 data up yet. Let's look at, which is a little confusing. I would think that they would. But yeah, I guess there haven't been any reports yet.
And where can we see that meteor shower?
Well, let's see if we can find out anything about this. Options and references? No.
I believe it's somewhere near the Big Dipper is the radiant.
Okay. I can believe that. Let's do a quick let's just do a quick looky here.
Well, if it's going to be right by the Big Dipper, I should have no problem catching any scatter, right?
Shouldn't. Nope. No problem at all. Are they going to show an actual radiant? There we go. Okay. So, they don't all come from here, but they're all going to point to this location in the sky, right? So they may be, way over, like in a different part, but they're all going to point to the radiant, which is right there. Whoop, I was hoping to zoom in a little bit here, but it zoomed out. There we go. So, I think at sunset right now, the Big Dipper is really, really low in the north. Some of us can't even see it, right? So you're going to have to wait until it sort of rises up a little bit. So, but look in the northeast.
So, like, we're both at the south, so there's a possibility we won't be able to do it yet. But maybe, like, let's say, like, local time, like 10, 11, or 12, we might be able to do something about it, huh?
Correct. Yeah. Once you can sort of see, the Big Dipper and, look for the handle, and it's sort of, just off the handle here, right? There's Arcturus over here, right? So yeah, but like I said, you don't necessarily have to look in this location they can appear all over the sky, but they're all going to point to this spot right there, right? They're all going to appear to be coming from that spot, but they may, they might be way over here, right? But it'll be moving this way, right? Away from that point. So cool, yeah. Well, if you're into meteor showers, that can be a pretty good one. So for sure. Let's see. So on the 5th, Venus is a half Venus at 19 hours. Must be really, really close to new moon.
What are you talking about? Earth Radio will be on at 8:30 on January 20th. I think you was talking about the eclipse, not the meteor shower.
That sounds correct. Yep, that sounds right. Yeah, depending on where you are on the planet, right? So yeah, you just have to be aware that this list I'm showing here and 99% of the time when I say, what time things are, I'm talking about UTC, right? That way I don't have to think, right? I just have to come up with one number and, you have to think. And that's okay, right? All right, cool. So let's keep going here. There is a partial solar eclipse that happens really, really late on the 5th. Looks like visibility is going to be more in the eastern hemisphere of the planet. So let's see, new moon takes place on the 6th at 1:28 UTC. So again, there, right? Being on Mountain Standard Time, I'd have to subtract 7 hours from this.
So, not sure you was checking the chat about Uncle Bill's comment and stuff. So you're saying it's better like before dawn and evening after dark, or what do you mean about that?
After midnight. After midnight is always best because the Earth is beginning to sort of spin into the path.
Okay.
The path of the meteors. So, always, getting out there after 12. Now that, you definitely don't have to, right? You'll see meteors right at sunset, right? You definitely will, for sure, right? But you won't see as many, right? Because most of them are going to be, below the horizon still. So, you have to wait until, 10, 11, 12, 2 a.m. Is a good time. Get up early.
So 2 a.m. local, right?
Local time. Yeah.
Right.
Or like I just said, get up early, 4 a.m. or so. That's a really good time to see those. Really, really good time, because it's going to be really high in the sky.
Maybe a great time to catch them scatter, right?
Absolutely. Yep.
I think I'm more focused on the scatter than the real thing.
See how you are? All right, cool. So, so there is a partial solar eclipse on the 6th. Venus is going to be as far away from the sun as it's going to be this time around, which is pretty far, right? Almost 47 degrees from the sun. So that's pretty cool. It's going to, of course, after this point, it's going to be getting closer to the sun as it whips its way around. So at this point, Venus is still on our side of the sun. Technically, Western elongation, I think, sort of defines when it starts to go onto the other side of the sun, right? I mean, it's still to the right of the sun, but technically, it's going to be on the other side of the sun at this point too. Uranus is stationary in right ascension. Okay. Moon is at descending node, which means it has crossed its declination of 0 degrees, moving south. Minimum libration. So libration, I forget what libration is. There's libration, there's nutation. We're going to have to look that up. I'm not going to do that at this point.
And I kind of like this analogy. It's more of us smashing the meteors than the meteors hitting us like a car driving through a bug swarm.
Oh yeah, that's exactly what it is, right? Meteor showers is caused by the Earth passing through, this trail of debris, and so for absolute sure, I mean, it's sort of a mutual thing though too, right? The debris is running into us, we're running into it, and we just so happen to be at the same place at the same time, and kaboom. So yeah. So let's see, on the 9th, the moon is furthest away from the Earth that it's going to be this time around. That happens every month, right? The apogee and perigee, which is the closest. That happens every month, of course. So, pretty close, or that's actually as far away as it's going to get. So Pluto is actually in conjunction with the sun at 12 hours UTC on the 11th. Now, Pluto is, I think, currently like about magnitude 14.7, maybe even 15th or so. So we're definitely not going to be able to see that with SOHO. I think we could. I think sometimes we can see Uranus. I'm certain that we can't see Neptune or anything like that. I think the limiting magnitude of SOHO is something like 4th or 5th, maybe 6th magnitude, maybe. I know that we can see a couple asteroids. So yeah, won't be able to see Pluto, but it's conjunction with the sun, which means it's on the other side of the sun from the Earth, sort of lining up with the sun. And let's see, on the 12th, Mercury is furthest from the sun that it's going to be this time around. See, that happens at 8 hours UTC. So Moon next to Mars. That, I don't know how exciting that is. Mercury and Saturn are going to be relatively close to one another. That's kind of cool. You can see some features on the moon, which is always fun. First quarter is on the 14th. So Mars is passing the ecliptic plane on the 15th, heading north. That's why it's called the ascending node. It's going up. Venus and Antares, that's not really all that close. I don't know why. I'm not exactly sure why that's so exciting, but okay. Moon sort of close to the Pleiades. That's kind of fun. Makes for a pretty picture. Also, when the moon gets close to these clusters, there's a higher chance of actually seeing the moon actually passing in front of these stars, doing an occultation. So that's kind of fun, to watch those. Let's see. I'm looking at the time, and I'm seeing that it's about 3:15 UTC. So we're about halfway through the month here. Why don't we call it for today? I don't like to go too much over an hour, although it usually does go over an hour. And not paying attention, I can go on for a lot more, but I try to pay
going back
close
with
attention
those
to these things.
meteor showers and stuff. It's better at 2 o'clock in the morning local or 4 o'clock in the morning local.
I would say either of those is just fine. I think the higher up the radiant is, the better. So I mean, I guess if you want to scale it that way, 4 o'clock is better. But you also have to consider, right, the cloud of dust that the Earth is moving through is pretty narrow, right? It's pretty small, right? It's sort of there's a little bit on the edge, and then there's a whole bunch in the middle, and then it sort of trails off again, right? So as the Earth moves through that trail, well, it's going to pass through thicker parts. So, actually the best time to see the shower is when the Earth is actually passing through the thickest part. And I don't think that anyone really knows exactly when that happens. They can predict it, right? And I guess the peak of this one occurs at 2:30 UTC tomorrow. So that is, in theory, when we're going through the thickest part of this cloud of.
So you said at 2:30 UTC or 2:30 local?
2:30 UTC is when we'll be passing through the thickest part. Now that probably doesn't coincide with 4 a.m. local time, right? So there's a little bit of balance there.
So,
right?
So if it's at the thickest point around that time, that's when you might have a better chance, right?
Absolutely, yeah. And depending on what part of the Earth you're on, somewhere, your local time is going to be 4 a.m. at 2:30 UTC, right? And so those two things.
I'm 6 hours behind.
Yeah. So but
at 2:30 UTC, that's usually 8:30 p.m. local here.
Correct. Yeah. So that would be when we're going through the thickest part, but at that time, your local time, the radiant is probably really low in the northeast, right? So you may not see the thickest part, right? But wait a few hours, wait till after midnight when the radiant is up a little bit higher, and that's only 3.5 hours after the thickest part. So your chances of seeing them still are pretty good. Yeah.
And the chances of scattered can be better as well, right?
Yep, absolutely.
Okay.
Absolutely.
So it's better tomorrow, right?
I think tomorrow night is probably the best night for us here, in the United States, at least.
Okay.
Yeah. All right, I'm going to check my chat once again really quick. All right, we're good there. All right, well, folks, I think I'm going to get on out of here.
Just, uh, you, you might be looking for the effect over the horizon. Is that possible?
The scatter Bobby is looking for a radio thing. Effect over the horizon. Yeah. Oh, I'm not sure about that, Uncle Bill. I'm thinking that you probably still want the radiant to be high, just to maximize the number of meteors, because you're actually looking at the radio emissions from these events, right? So I mean, it's just light, right? I mean, it's just a different wavelength of light. That's all it is. So yeah, I'm not too much tuned into that. Might require just a little bit of research, to figure all that out. But listening to meteors is very, very cool. If you've never heard a meteor shower through a radio, it is very, very, very cool. Very cool. You can probably go onto YouTube or something, type that in, and listen to it.
Skills did say that if you are around the FM range, you might have a better chance.
Okay. Yeah. I don't even know what the frequencies are. I remember as a kid, I think I was told, that if you tuned your TV to, channel, I don't know what, you could actually hear brighter ones, through your TV. But yeah, I would say go onto YouTube, do a search for, listening to meteors with radio, and you probably get some sounds that way. Really, really, really cool, to hear those kinds of things. So, all right. All right. Well, cool. I think I'm going to get out of here for today. So thanks, everybody, for coming in again, sharing the passion. That's all we're doing here. Thinking astronomy, talking astronomy, doing some science, some space, looking at dark rocks, with, yeah, awesome stuff. Very, very cool. All right. I'm going to get out of here. So have a great evening, a great day. Thumbs up, thumbs down, make some comments, subscribe, hit the bell, spread the word, this channel is slowly growing, and I think that is cool, because sharing the passion, spreading it around, that's what it's all about. So, all right, everybody, take care. I will see you in a little less than 23 hours from now. All right, take care. Bye.
Later.
Bye.